Welcome to the introductory video on correlation. Let me just get a title up here for us. So, introductory video on correlation. So, correlation in and of itself is just a descriptive statistic. And really what it's going to do for us is describe descriptive statistic describing, and we just put here describing the relationship between two variables. Relationship between two variables. Two continuous variables. I'll put in here continuous. Two continuous variables. So going back to the video on scatter plots, and if you haven't already seen that video, please go back and watch it. But if you remember, we essentially plotted paired data, and this is important here that correlation uses pairs or sets of data scores, if you will, for each person. So going back to that scatter plot example from the other video, if you had something like, person here, and you had person A, and you had a value for their sit-ups, and there was a number here or a frequency, and then you had a value for their push-ups, and there was a number or a frequency here, then what you have now is a set of paired data. You have a push-up value, and you have a sit-up value for person A. And that's what you have to have. And now what you want to be able to find is what is the relationship between their ability to do push-ups and their ability to do sit-ups. Now we can quickly get a visual representation of this relationship by plotting the scatter plot, and all the common statistical programs like SPSS and SAS and Statistica and those other ones will do this for us, and that will help us give us an established pattern. But if you're wanting to get an exact mathematical relationship, then you can calculate this using an equation. Now we're going to do that in another series of videos, but right now we just kind of want to give a really kind of just surface level introduction to what this is. So the correlation coefficient, or correlation can be expressed as a coefficient, it's probably a better way of saying this, expressed as a coefficient. Now we'll get into the math of this later, but the coefficient is termed r. I'm going to put it in quotes here, but it's just lowercase r. It was developed by Carl Pearson, and it will actually be called the Pearson product moment correlation, and again we'll get into the math of this later, but r is just going to be a numerical value for us, and it's going to have a range. So r will range from -1 to positive 1.00. Okay, so that's our range. So let's just talk about this in a little bit more detail. Maybe we'll give some kind of graphical illustrations here. So a correlation, or a r equal to 0. Well, what does that mean? Let's just give kind of a quick graphical illustration. So let's give a y-axis, and let's give an x-axis. Okay, and let's just say that this is, again, push-ups, sit-ups. And, you know, we can do this now that we've already talked about scatter plots. And if you haven't seen the video on scatter plots, again, go back and see that. But, you know, if you have data in here that is kind of dispersed like this, such that if you were to draw a line of best fit through it, you know, you have to get equal distances above and below the line. You might look something like this. And if we were to draw kind of a circle around this, it's very dispersed out, very circular dispersion of the pattern of the data. You very much expect this correlation to be very close to zero, maybe a little positive above it or a little negative below it, but pretty much going to be an R of 0. What would an R close to positive 1.00 look like? Well, again, let's just kind of go to a little graphical representation here. Let's give a y-axis and an x-axis. And so now this is kind of going back to the same, you know, kind of push-up, sit-up data that we were looking at before. You might have something that kind of looks like this. And so with something like this, again, just do a line of best fit here in blue. You might have, I don't know, something that looks like that. And all of the plotted points are much more closely aligned in this kind of oval. And it's starting down here in the origin and moving up into the right. And so we call this a positive correlation. You're seeing this positive 1.0, but this is a positive linear correlation. So let's look at, well, I guess let's just go back just for a second. Let's make sure we understand what positive means here. It means that as you're increasing, as you're kind of increasing in values of x here, you are correspondingly increasing in values of y. Okay, so you're increasing in y, you're increasing in x, or if you're increasing in x, you're increasing in y. Same thing. So let's look at what an R, if it can range between -1 and 1, let's look at an R equal to -1.00. Let's quickly get a pair of axes back on here. X, Y. Okay, so you have something now that looks kind of like this. This is still push-up data, sit-up data, and you've got maybe something that looks like that. Let's put our line of best fit in here. Okay. And again, we have a nice tight kind of oval shape here to the data that they all want to kind of fall close to that line. And because of that, you would expect, let me try that again. And because of that, you would expect this relationship to be strong, and it is, and it's almost perfectly strong, but in a negative direction. So we're going to call this, because again, referring to our negative sign here, we're going to refer to this as a negative linear correlation. Okay, now what does this mean? Well, it means as you're increasing in y, and you can see this in the very first thing, so as you're increasing in the y variable here, you are decreasing in the x variable. And that makes sense here because this point right here is very high on the y-axis up here, but it's very low on the x-axis down here. And so this would be an example of a strong negative linear relationship. So this is just kind of the real basics of what a scattergram or a scatter plot might look like relative to the concept of the correlation coefficient. So again, it's bounded by +1 and -1. Things that are closer to 0 are going to pretty much have no relationship. Things closer to this -1 or +1 are going to be, you know, either positive or negatively linearly related. So I hope that gives you again an intuition of tying the scattergrams back into an R. Thanks for watching the video.